Okay, so moving on to example 5. Again, we're still working with equating coefficients of two equal polynomials. So this time it's a little bit more complex. We have our first polynomial here is a times x plus 1 squared plus b times x plus 1 plus c, and that is going to equal our second polynomial, which is 5x squared plus 7x minus 2. So in the previous example, we had our coefficients that we were looking for were already expanded out, and the second polynomial was not, and we had to expand that. Now we have to do this in reverse order. We have to expand out the left polynomial in order to get it to look like the right side. So we're going to be dealing with the left side here. So we need to perform each operation as we go down. So this term here, we're going to have a times x plus 1 squared. Well, that's the same thing as a times x squared plus 2x plus 1. Our b of x, or b times x plus 1, makes simply that, b times x plus 1. And our c is lastly by itself. Okay, so we still haven't broken this apart yet. So what we need to do is, for each of these terms, we need to go ahead and continue to expand this. So here we've got ax squared plus a times 2x, which makes 2ax, and then a times 1 makes a positive a. This b term, so we're going to have b times x plus b. And obviously the one with c, we don't need to worry about that. So if we put all these three together, okay, you want to see that we want to put them together with the like degreed items. So like we have an x squared here, we have an x, we have a constant. All three of those need to go to different places. So let's look through this whole set and say, okay, so we've got one term with x squared. So we're going to put that term over here, a times x squared. Then we need to look all of our terms that have x in it. Well, we've got 2ax and we have a bx, so we're going to put those together. So we're going to have plus 2ax plus bx. And you'll see why we're doing this in a second. And then all our constant terms, our positive a, our positive b, and our positive c, makes positive a, positive b, and positive c. So this is what this looks like all expanded out. It looks similar to what we have on our blue polynomial, but we're not ready just yet to make any kind of statement about the values of a, b, and c. We've got a little bit more work to accomplish. So what we need to do now is we need to get, like we have over here, x squared times a single thing. We need to get the x times a single thing, and we need to get our AB, and we need to get our constants all together. So we're going to factor, and we're going to make sure that we put all of these things in the right place, so that we have three different things. Well, we have one x squared term, so that stays the same. We have ax squared. We have two terms with x in it. We need just one term, like we have up here, positive 7x. So how do we count the number of x's? Well, that's what factoring does. It counts the number of things. So if we factor an x out, and this is going to look different because normally we factor out to the front, but I'm going to factor to the back side here. How many x's do we have in this box that we have? Well, there's 2a x's in this first term, so we have 2a, and then we have b here. So if we take that away, we take the x away from both of those, you can see that we have 2a plus b x's. So if you imagine factoring the x's out here again, you're left with 2a plus b because we have 2a x's and we have bx, so the total together is going to make 2a plus b x's. That's what factoring does again. Then we have at the very end our constants, and so we're going to put all these together. We're going to put the a, the b, and the c together. So now we actually have this in a form that we can work with. We can see here that we have our single x squared term. Well, x squared, ax squared goes with 5x squared. So we say if ax squared equals 5x squared, then a equals 5. And we move on. We have our 2a plus b times x. That is going to equate with our 7x. So we say if 2a plus bx equals 7x, then we have 2a plus b equals 7. Well, okay, so we learned before that a equals 5. So we can actually input that in to our problem at the bottom. So we can see that we have 2 times 5 plus b equals 7. Well, this is 10 plus b equals 7. And so we can find that b is going to be a -3. So far we have a and b. Well, now we have to go back and find what our c value is. So we go all the way up again, and we're going to switch to say, okay, well, if positive a plus b plus c is the same thing as -2, then we can say, well, a plus b plus c equals -2, but we know what a is, right? A is 5. And we know that b is -3, and so then we have plus c equals -2. So this makes 2 plus c equals -2. So we have c to equal -4. So this is a more complicated example, but it's mainly about saying that if we know what the degree of x is attached to coefficients of two equal polynomials, then we can set those things equal to each other. So it's mainly about staying organized, making sure that we do our operations correctly, and then once we finally get to the form that we want, the equal form, then we can go ahead and say what our coefficients are, and we can make those statements.